Let us learn the next formula of integration. Integral e raised to x times f of x plus f dashed of x dx. This will become e raised to x into f of x plus c. Write down this formula in the formula notebook. And this formula has been given on page number 327. Then mark this formula, the first line. Let me explain this formula. The left hand side, open the brackets and write. So it becomes e power x f of x dx plus integral e power x f dashed of x dx. Let us do by parts of the first term. In I late, e comes last. So e power x is the second function, f of x is the first function. First function into integral of the second function. Integral of e power x is e power x minus integral differential of the first function. Differential of f of x is f dashed of x into integral of the second function dx. And copy the last term. Now these two terms are getting cancelled. Therefore, the answer becomes e power x f of x and plus c. If you have integral of e power x and sum of two functions such that one is f of x, the other one is f dashed of x, the answer becomes e power x f of x and plus c. Let us continue exercise 7.6. Question number 16. Integral e raised to x sin x plus cos x times dx. Write the formula. E power x f of x plus f dashed of x dx becomes e power x f of x plus c. And here f of x is sin x and f dashed of x is cos x. Therefore, the answer for this question is e power x f of x, which is sin x, and plus c. Question 17. Integral x e power x divided by 1 plus x the whole square dx. If you have e power x and a bigger expression, always try to split it as f of x and f dashed of x. Since the denominator has 1 plus x term, let us try to write numerator also in terms of 1 plus x by adding 1 and subtracting 1. Now separate the terms. 1 plus x divided by 1 plus x the whole square becomes 1 divided by 1 plus x, and this becomes 1 divided by 1 plus x the whole square times e power x dx. Let us write the formula. Integral e power x times f of x plus f dashed of x dx is equal to e power x times f of x plus c. Now f of x in this case is 1 divided by 1 plus x. Let us check whether f dashed is minus 1 by 1 plus x square or not. This can be written as 1 plus x whole raised to minus 1. Therefore, f dashed of x will be minus 1 plus x raised to minus 2, which is minus 1 divided by 1 plus x the whole square. Therefore, the first term is f, the second term is f dashed. I can apply the formula here. Therefore, the answer becomes e power x times f of x. f of x is 1 divided by 1 plus x and plus c. This is the answer. Question 18. integral e power x times 1 plus sin x divided by 1 plus cos x. This is an important type. I have told you if you have e power x and a bigger expression, try to separate the terms as f of x plus f dash of x. 1 plus cos x is 2 cos square x by 2. 1 plus sin x can be written as 2 sin x by 2 cos x by 2 times dx. Let us separate the terms. 1 divided by 2 cos square x by 2 becomes half secant square x by 2 plus the second term. 2 gets cancelled, 1 cos term gets cancelled. Sin x by 2 by cos x by 2 becomes tan x by 2. And we know that differential of tan is secant square. The formula is integral of e power x into f of x plus f dashed of x dx equals e power x f of x plus c. Now let us see which one is f and which one is f dashed. F of x is tan x by 2 and f dashed of x is differential of tan is secant square x by 2 into differential of x by 2 is half. Chain rule. But this formula is applicable only when you have e power x in the question without any coefficient. If you have some coefficient for x, that coefficient will come in the answer. You won't get e power x f of x in that case. It will be divided by the coefficient. So if you have some other coefficient for x term, it is better you split it into two integrals and integrate the first one and cancel the second term. Applying the formula, we know that this is f and this is f dashed and we have e power x. Therefore, the answer becomes e power x times f of x. F of x is tan of x by 2 and plus c. Nineteenth question. Integral e power x times 1 by x minus 1 by x square dx. This is such a simple question. Let us write the formula. In this question, f of x is 1 divided by x and f dashed of x is differential of 1 by x is minus 1 by x square, because this can be written as x raised to minus 1. So minus 1 x raised to minus 2 it becomes, which is minus 1 by x square. This is f and this is f dashed. Therefore, the answer becomes e power x f of x plus c. Question 20. Integral x minus 3 divided by x minus 1 the whole cube e power x dx. Again I am repeating, if you have e power x function and a bigger expression, split it into two such that one is f, the other one is f dashed. The denominator has x minus 1 the whole cube. So let us write the numerator also in terms of x minus 1. I can write x minus 3 as x minus 1 minus 2. Let us separate the terms. X minus 1 divided by x minus 1 the whole cube becomes 1 divided by x minus 1 the whole square minus the second term is 2 divided by x minus 1 the whole cube multiplied with e power x dx. Now let us check whether we have it in f and f dashed form. I will write the formula. In this question, f of x is 1 divided by x minus 1 the whole square, which can be written as x minus 1 whole raised to minus 2. Let us differentiate and check. Power has to be differentiated first, so minus 2 times x minus 1 whole raised to minus 3, and then the base has to be differentiated, which is 1. We get minus 2 divided by x minus 1 the whole cube. The same function is there. This is f and this is f dash, and we have e power x. Therefore, the answer becomes e power x into f of x. Here f of x is 1 divided by x minus 1 the whole square, and plus c. Now we will do 24th question. 24th question is of same type. Integral e raised to x secant x into 1 plus tan x dx. This is again a very simple question. Let us open the brackets. We get secant x plus secant x times tan x and dx. We know that differential of secant x is secant x tan x. Let us write the formula. So directly you can apply the formula when the coefficient of x is 1 in e function. Otherwise the answer won't be e power x f of x if there is a coefficient. Equal to e power x f of x is secant x and plus c. So the correct option is B. Page number 327. Let us do example 22. First subdivision. Integral e power x times tan inverse of x plus 1 divided by 1 plus x square dx. This is so simple, direct question. This is f and this is f dashed. Write the formula and apply that formula, so we get the answer e power x tan inverse of x plus c, and the formula is, write the formula. Now second subdivision of example 22. Integral x square plus 1 divided by x plus 1 the whole square into e power x dx. This is an important question. Put a star in your textbook for this question. Okay, let us see how to split this function. We have x plus 1 the whole square in the denominator. So we need to write numerator also in terms of x plus 1. So what I am going to do is, I will write this as x square minus 1 and plus 2. X square minus 1 plus 2 is x square plus 1. E power x dx. Let us separate the terms. X square minus 1 divided by x plus 1 the whole square, and the second term is 2 divided by x plus 1 the whole square, and e power x dx. Let us simplify the first term. We can factorize the numerator as x minus 1 times x plus 1, and denominator is x plus 1 whole raised to 2. So that one factor gets cancelled, and write the rest of the terms. Now we have x minus 1 divided by x plus 1. plus 2 divided by x plus 1 the whole square times e power x dx. Now we have it in f and f dashed form. This is f and this is f dash. Let us check. I'll show that differentiation here. F of x is x minus 1 divided by x plus 1. F dashed will be, we have to apply quotient rule. V square in the denominator. U dashed is 1 into V minus U into V dash. V dashed is again 1. Now x gets cancelled. You get 2 divided by x plus 1 the whole square. Write the formula. So by using this formula, the answer becomes e power x, and f of x is x minus 1 divided by x plus 1 and plus c. Now let us learn the next type. Write it down in the formula notebook, the next formula. If you have integral of e power ax sine bx dx or integral of e power ax cos bx dx. In such cases, integration by parts is applied twice. So use integration by parts method 2 times and then take I term, that is the integral which is given in the question, which is on the right hand side to the left hand side, and find the answer for the integral I. So when we do the question, I will explain this second step. Write this method in the formula notebook. This method is applicable when you have exponential function and sine or cos functions. Exercise 7.6, question number 21. This question comes under this type. Integral e power 2x sine x dx. We have e function and sine function. Let us use by parts method. In I late, e is the last letter, so exponential function is the second function, sine x is the first function. The formula is integration by parts formula. First function into integral of the second function minus integral differential of the first function into integral of the second function dx and plus c. So integration by parts method should be applied twice for such questions. First function is sin x into integral of the second function. Integral of e power 2x is e power 2x and divide by the coefficient of x, 2, minus integral differential of sin x is cos x into integral of e power 2x is e power 2x divided by 2 into dx. We will write c at the end. No need to write now. This is equal to sin x into e power 2x divided by 2. Here 2 is a constant. Half can be taken outside. Look at the question. The question had e function and sine function. Now after using by parts method once, we are getting e function and cos. If you do it again by parts method, you will get e and sine. We won't be able to get rid of this e and sine or e and cos functions. So let us see what to do. We have to apply by parts method again for the second time. sin x into e power 2x by 2 minus, this is second function and this is the first function. First function into integral of the second function minus integral. Differential of cos x is minus sin x, so minus of minus plus sin x into e power 2x divided by 2 dx. See, now we got e and sine function in this integral. The question also has e and sine function. Okay, let us open the brackets and write sin x into e power 2x divided by 2. Distribute this half. 1 by 4 cos x into e power 2x minus 1 by 4. I can write this integral sin x e power 2x dx as I. If I take the given integral as I, so on the left hand side I have I, on the right hand side also I get I term, but the coefficient is different. We have to find I. Let us bring this I term to this side. That's what in that method it was given. Take I term which is on the right hand side to the left hand side. We get I plus 1 by 4I, which becomes 5 by 4I, which is equal to e power 2x divided by 2 is common. We get sin x minus half cos x. Now we have to find I. Take 4 by 5 to the other side, or we may cancel 2 here. So it becomes 2 by 5 times e power 2x into sin x minus half cos x and plus c. Write plus c at the end. Example 21 is also of same type. Let us do example 21. Integral e power x sin x dx. Use by parts method. This is the second function. Sin x is the first function. First function into integral of the second minus integral differential of the first function. Differential of sin x is cos x into integral of e power x is e power x. We have to do integration by parts 2 times for such questions. For which questions? If you have e and sine or e and cos functions. E power x times sin x. Let us use integration by parts method again. Minus of, use brackets because minus is common to both the terms which we are going to write. First function into integral of the second minus integral differential of the first function. Differential of cos x is minus sin x, so plus sin x it becomes here, into e power x integral of the second function dx. Let us take the given integral as I. E power x sin x, distribute this minus sign, e power x into cos x minus, I can write this as I. Here also I have I. Now take this I which is on the right hand side to the left hand side. It becomes 2I. E power x is common in these two terms. Now find I. So I is e power x divided by 2 times sin x minus cos x and plus c. Now in exercise 7.6, question number 22 and 23 are left. They are very simple questions. Question number 22, integral sine inverse of 2x divided by 1 plus x square dx. We have formula for this which we studied in inverse trigonometric function lesson. This is 2 tan inverse of x. 2 is a constant, so take it outside the integral. We know that we don't have direct integration formulae for inverse trigonometric function as well as log function. In such cases, we take 1 into tan inverse of x, then 1 should be taken as the second function and tan inverse as the first function and use by parts method. Let us write by parts formula. Two times first function into integral of 1 second function, which is x, minus integral differential of the first function. Differential of tan inverse is 1 by 1 plus x square, into integral of the second function. Integral of 1 is x dx, which is equal to 2x tan inverse of x minus, this can be done by substitution, 1 plus x square as t. Differentiate both sides. This becomes 2x dx is dt. We have 2 here. We have to distribute this 2. 2x dx becomes dt divided by t. 2x tan inverse of x minus integral of 1 by t is log of absolute value of t and plus c. Substitute for t. 2x tan inverse of x minus log of 1 plus x square is a positive number, so I need not write the absolute value sign, and plus c. Question 23. Integral x square e power x cube dx. We know that differential of x cube gives us x square term. So let us use substitution. We can take x cube as t, or we may take e power x cube as t. Let us take x cube as t. 3x square dx is dt. Therefore, x square dx is dt over 3. Let us substitute. This becomes dt divided by 3, and this is e power t. So simple it has become. Integral of e power t is e power t and plus c. Substitute for t. T is x cube plus c. So the correct option is A. Example 40.
This is an important question. Put a star in your textbook.
Integral log of log x plus 1 divided by log x the whole square into dx. So for this question we are going to use integration by parts 2 times. Let us separate and write the integral. First integral is log of log x into dx, and the second integral is integral 1 divided by log x the whole square dx. We are going to use by parts method. Let us take 1 as the second function here, and log of log x is the first function. Integration by parts formula. First function into second function dx is first function into integral of the second function minus integral differential of the first function into integral of the second function dx. First function is log of log x into integral of the second function. Integral of 1 is x minus integral differential of the first function. We have to apply chain rule. Log of log x. Differential of this log x is 1 divided by log x, and then differential of this log x is 1 by x into differential of x is 1. So it is 1 divided by log x into 1 by x. And then integral of the second function. Integral of 1 is x dx, and write the second term. X into log of log x minus, we can write this as log x whole power minus 1 dx plus 1 divided by log x the whole square dx. We will use by parts method for this integral. We will take 1 into 1 is the second function, and log x whole power minus 1 is the first function. First term is x into log of log x minus of, use brackets because we are going to write two terms. Minus sign is common to both the terms. First function into integral of the second function. Integral of 1 is x minus integral differential of the first function. Log x whole power minus 1 has to be differentiated. So differentiation will be minus 1 into log x whole power minus 1 power minus 2, n into x power n minus 1 formula, into the base has to be differentiated. Differential of log x is 1 by x. So it is minus of log x whole power minus 2 into 1 by x. This is differentiation of the first function, into integral of the second. Integral of 1 is x dx, and the last term is integral 1 divided by log x the whole square dx. X into log of log x minus x divided by log x, and here we have three negative signs. This minus has to be distributed, so it becomes minus integral 1 divided by log x the whole square dx, and the last term integral 1 divided by log x the whole square dx. These two terms are getting cancelled, and we will add plus c here. Therefore the answer is x times log of log x minus x divided by log x and plus c.